Hi, my name is Kailash, and today I'm going to present about PBL2's introduction. So, uh, we are going to we have to understand the digital modulation method for this PBL, which is known as a pulse code modulator, which is used to which is a thing used for digital modulation process. Okay, next, in the whole outcome is going to be we are going to learn the benefits and the outcome of PCM, okay? And then we are going to build a PCM circuit in MATLAB using Simulink so that we can test and simulate its working principles, okay? Then next, so basically how the thing works is, how a PCM works is, it converts analog signals into digital signals, okay? And then it can also decode the same signal, the digital signal to analog signal at the receiver. Usually this happens at the receiver. Okay. So when the process of decoding it and encoding it is almost 100% the same. So basically you decode the analog, go to digital, the analog again, it's the information is 100% contained. It's carried there, no loss, anything, loss of information. It's almost that precise and effective. Okay. So we are gonna understand. We are gonna learn about simulate about that. Other than that, yeah, the encoding and decoding is very good using PCM, and in the process of digitalized encoding and decoding, sampling, PCM helps us to gain the exact same shape of the wave of the information wave, as you can see when doing simulation in the graph. So yeah, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Farhan Bimo Faisal, and I will presenting about the simulation. So, uh, this is for the part A, which is given in two scenario, which is the first scenario is for bit. Okay, we set it off in for bit. Okay, and then we run. As you can see here, there is the modeling system in for bit. Consider sampling pulse signals in the output here. And then we move to the scenario 2, which is take. As you can see here, there is a take bit here, here, and here. Okay, here are it. So this is the signal we get from the take in the model signal, sampling pulse signals, and the output here.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haji Azhar bin Badrul Zaman, matrix number CE210197, and I will continue to explain for this next part, which is part B and part C for scenario 3, 4, and 5. So in part B, the question is for the sampling, which is for empty, is required more than according to the NIPIS, which is our sampling frequency is 2 FM, which is 200 Hz, and we will provide new value, and our team choose to the new value is 400 Hz. And next for the sampling period, for the TS, our value is 1/400, and we change in here. This sampling pulse. First, we change the period is 1/400. According to our team, they choose 400 Hz for the new value. The second, choose 400. And in the scenario 3, the n bits encoded PCM data is 4. So we change all the bits into 4. 4 integer to bit converter, 4 bit to integer converter, 4, and lastly decoder 4 bit. The value of amplitude all is the same, which is 5, based on our equation. And we set the start time, which is 0.5. And we just need to run. We will get this is our result for the input, sampling signal, template signal, quantized signal, and encoded signal. Next, this is our output and input result. Here, this is our input and output result. Okay, so next, for the scenario 4, we just need to change the n bits to be 8 bits. From the 4 bit become 8 bit. So other than that, we do not have to change the value. So right here in encoder, we change to 8 bit, apply, okay. Integer to converter, 8 bit, okay. Lastly, decode LP. And just we need to run the simulation. This is our result, which is we can see the quantized signal is become more higher. The value become more higher than 4 bit. Then we will see the output and input result. You can see it's remain the same, but the value is different. Which is I will show the value in the slide. Okay, next we will continue for the next part, which is part C. Okay, in part C, which is for scenario 5, the question is sampling for MT it need to be lower than minimum required according to Nyquist, which is our sampling frequency is 200 Hz. So that our new value needs to lower than 200 Hz, but higher than our required value, which is 100 Hz. So I choose the value is 180 Hz. So we need change of the sampling pulse is we change to 180 live. Okay. Moderating signal, we also change the 150 light and change. Okay. So we change the bit first. We need the question is set the bit into 4 bit only. So we change the value 4 bit. Okay. 4 bit. 4 bit. Other than that, we just remains. Okay, so in here we need to set up the analog filter to make the output and input sine wave more smooth, and we just need to change it in here. Okay. Then we just need to run the value. Run the simulation. So here's our result for the input, sampling signal, quantized signal, and encoded signal. And for our we will see the output and input. As you can see, the output and input sine wave is more smooth than before because we set at the flow rate. That's all for the part B and part C. For me, thank you. For scenario 3 part B for bits, the equation is need to get the new value which is more than 2 FM. So our team member choose 400 Hz. And so this is our result for the quantization error, which we get 4 quantization error. First 4.969, second 7.986, third 11.662, and lastly 10.803. So for the code number is 0, and for the PCM sequence is 0000. For number 2 is 7, and the PCM sequence is 0111, and number 3 is 13, and the PCM sequence is 1101, and lastly 10, and PCM sequence is 1011. And this is our input and output result, which is for the input we get 4.9x volt and the output is 4.362. So the difference between the maximum amplitude is 0.636 volt. And the input for 1 complete cycle is 5 milliseconds. Same for input and output, so there is no difference of 1 complete cycles. And for the input frequency is also same, which is our new value is 400 Hz, and there is no difference of frequency. For part B 8 bits, for the scenario 4 is also same like scenario number 3. But so this is our quantization error value, which is we also have 4. For the first one is 21.6x9, number 2 is 7.676, and number 3 is 12.479, and lastly 7.401. We will get the code number for number 1 is 18 with the PCM sequence is 00010010. For the code number 2 is 0108, and the PCM sequence is 01101100. And our code number 3 is 218 with the PCM sequence 1101110. And lastly, for the code number 4 is 126 with the PCM sequence 01111110. And this is our input and output result, which is the input maximum amplitude is 4.99x volt, and the output maximum amplitude is 4.624 volt. And the difference of the maximum amplitude that we get is 0.374 volt. And also the input for 1 complete cycles is remain same between the input and output, which is 5 milliseconds, so there's no difference. Same goes to the input frequency and output frequency, also same 400 Hz, and there is no difference of the frequency. For the last part C, 4 bits, for scenario 5, we need to get the new value for the fs, which is less than 2 FM. So our team choose for the new value is 180 Hz. And this is our result for the part C, which is for the input value is 4.996 volt, and the output value is 4.660 volt, which is the difference is 0.336 volt. And for the input and output, 1 complete cycles times is same 5 millisecond without the difference, and also the frequency we change the value is 180 Hz. So the difference of the frequency is remain same, which is 0.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fernando Jafar. My meeting number CE210050. Okay, for my parts, I will explain about part D. The question is, with the incident setting part B remain, what will happen to the cover message MT if amplitude of MT is changed to VM equal to 50 and VM equal to 0.5. Okay, first of all, we must setting the sampling pulse signal to first period 1 over 400 and the amplitude is 15. Okay, this also the amplitude is 15 and frequency is 0 100. Sorry, we're using 400. Okay, this we first of all we peak is 5 and bits is 4. uh, we start with the 4 bit. Okay, 4 bit also, and you can decoder for 4 bit. Okay, after that we can run to get the graph, output graph. The output graph we can get this, and you get the amplitude for the graph. Okay, then that the one this like this. We continue with using the amplitude with 4. Just change encoder is 8 and decoder is 8. 8 bit converter is 8. Okay, to make sure the amplitude is 15 and frequency is for 400. Just make sure. Okay, and you can run again. Okay, you can see we must set up the set the method of 15. The period is 1 over 400. Frequency is 400. Peak 15 bits for the output result for 15 word 4 bits can come out with this output waveform for bits encoder PCM display, and this is the output waveform of oscilloscope. Okay, after that we continue for the parts, then n bit encoder PCM data coding change to 8 bit. We just change the bits of the circuit is a bit in 8. Okay, and then the output is result for signal 7. We come out with this, the output waveform of 4 bits encoder PCM display, and this is the output waveform of oscilloscope. Okay, the input is 15 for scenario 6 and scenario 7. Okay, you can see the for scenario 8, based on given situation, we given the output up the amplitude to 0.5 volts, and same so heading to part B and remain between first. But firstly, we simulate the result when n bit correlation data is 4, then the followed by the 8. Okay. The same goes to scenario 6 and 7. We just change the amplitude 0.5. Frequency actually is to 400, 2000. Okay, and bit is 4. Can come out as a result for scenario 8 is here. Okay, and the waveform of oscilloscope come up with this waveform. Okay, for scenario 9, the it just change the bit is to 8. Okay, this is the output of waveform for 4 bit encoder PCM display, and the output of oscilloscope. Okay, for scenario 8 with a 4 bit, and scenario 9 is an 8 bit. Okay, that's all. Thank you.
So, here for the conclusion part, we can conclude that after performing this activity, we can conclude that pulse code modulation (PCM) contains important principles such as B, sampling, quantization, coding, pulse shaping, and decoding. So, pulse code modulation (PCM) is the simplest form of waveform coding. Waveform coding is used to encode analog signals such as voice into digital signals. Then we use the digital signal to reconstruct the analog signal. Modulation is the process by which the characteristic parameters of a radio frequency signal change in proportion to the amplitude of two communication signals. Modulation is also used to send low frequency message signals over wired or wireless media. Sampling is not transmitting an analog signal as it is, but transmitting and observing a sample on the receiving side to judge the actual signal. It is used to it is used in impulse code modulation technology where continuous analog signals are sampled, quantized, digitized, modulated, and then transmitted at discrete time intervals. All the samples come together to convey the actual signal information. So that's all from our group. Thank you.